Hello children. Today we are going to discuss about another concept of limits and continuity. In our previous class, we had a discussion about exponential functions, logarithmic functions, and how to differentiate exponential function and logarithmic functions. That we have discussed very clearly. Now today, another interesting concept we are going to discuss, that is logarithmic differentiation. Differentiation of logarithmic function is different. Logarithmic differentiation is another different. So what is the meaning of logarithmic differentiation and how to differentiate it, and when we need to use this kind of differentiation, that we are going to learn today. Now, any function is in the form of y is equal to u of x power v of x. Usually we have e power x, which is exponential function. A power x, it is also another function. Now, what is the concept we are discussing is, when there is a function u of x power v of x, means the base we have a function, the variable x, the power is also you have a function in terms of x. When the base and the power both are functions, they may be trigonometric function, they may be algebraic function, they may be inverse trigonometric function, or they may be exponential function, or they may be logarithmic function. Any kind of function it may be. There is no particular condition u of x has to be only trigonometric or v of x has to be only trigonometric. There is no such kind of conditions. These two functions are maybe any kind of function, maybe any kind of functions. Whenever there is a problem in this form, whenever there is a function in this form, then how to differentiate? So, to derive this kind of function, we are going to use logarithmic differentiation. What we are going to discuss? Logarithmic differentiation means, first we apply logarithm, then we go for differentiation. Step 1 is what? Applying logarithm. Step 2 is what? Then going for derivation. That is nothing but called logarithmic differentiation. What it is? Logarithmic differentiation. For example, when we apply logarithm on both sides, I have log y is equal to log of u of x power v of x. Whenever we apply logarithm, the exponent comes as coefficient. That we have a formula. Now what it became? Now it converted as v of x into log u of x. How it is there? Now I have a product, means it is a function and it is a function which is in the form of uv. It is in the form of what? uv. Now you can go for derivation. This is nothing but logarithmic differentiation. This is nothing but what? Logarithmic differentiation means, whenever you find a function in the form of u of x power v of x, if they ask to find derivative of this function, then we need to follow logarithmic differentiation method. Then we need to follow which method? Logarithmic differentiation method. Means, first step we apply logarithm on both sides. Second step we go for differentiation. Now, using this method, let us see how to solve the problems. Let us go for example number 30. What is given example number 30? Differentiate square root of x minus 3 into x square plus 4 by 3x square plus 4x plus 5 with respect to x. With respect to x. Now, to see the problem, it is a big problem. We have different types of functions and we have square root. Now, how to solve this problem? How to solve this problem? Now, to solve this problem, we are going to follow the method logarithmic differentiation. Which method we are going to follow? Logarithmic differentiation. Let us observe carefully so that you can understand very easily the concept. First, given. What is given? Y is equal to square root of x minus 3 into x square plus 4 by 3x square plus 4x plus 5. Apply logarithm on both sides. Apply logarithm on both sides. When we apply logarithm on both sides, what we have, that is log y is equal to log. Let us multiply these two now so that your calculation will be very easy. Otherwise, you need to go for UV product, UV multiplication you need to do. Instead of that, you can multiply x into x square, x cube, minus 3 into x square, minus 3x square, x into 4 plus 4x, minus 3 into plus 4, minus 12, by the denominator we have 3x square plus 4x plus 5 power 1 by 2. Square root is what? Power 1 by 2. Now, that implies log y is equal to, whenever we have a logarithm, the exponent comes as a coefficient. That we have a formula. So, 1 by 2 into log x cube minus 3x square plus 4x minus 12 by 3x square plus 4x plus 5. So this is the function I have. Now go for, now what? Go for logarithm. Again we have log. It is in the form of log u by v. It is in the form of what? Log u by v. Means log y is equal to half into log x cube minus 3x square plus 4x minus 12 minus log 3x square plus 4x plus 5. So this we have. You need to follow the formula. In our previous class, I had given list of formulae related to logarithms. Those formulae definitely we have to learn. Then only you can understand the concept. In y logarithm, when we are having, exponent comes as a coefficient whenever we have a division. So log u by v means log u minus log v. Now what I have, log y is equal to half into log x cube minus 3x square plus 4x minus 12 minus log 3x square plus 4x plus 5. Now we go for the differentiation. Now we go for differentiation. Differentiate on both sides. Differentiate on both sides with respect to x. Differentiate on both sides with respect to x. That is d by dx of log y is equal to half into dy dx of log x cube minus 3x square plus 4x minus 12 minus dy dx of log 3x square plus 4x plus 5. So now I am differentiating on both sides with respect to x. That implies log y derivative. What is the derivative of log y? 1 by y. So we have 1 by y into dy by dx. Why we get dy by dx? Actually what we are doing, we are deriving with x, but instead of x what we have? Y. So that log y derivative is 1 by y. Again y also we should go for differentiation, so that we have dy by dx. That is equal to half. It is also in the form of what? Log x. That is also in the form of log x. Log x differentiation is what? 1 by x means 1 by x cube minus 3x square plus 4x minus 12 into d by dx of x cube minus 3x square plus 4x minus 12. Because log x derivative is 1 by x, but in place of x what we have? This entire function. That also we should go for differentiation. A function in another function. Minus again log x. Log x means what? 1 by x means 3x square plus 4x plus 5 into d by dx of 3x square plus 4x plus 5. This we have to go for differentiation. That implies 1 by y into dy by dx is equal to half into 1 by x cube minus 3x square plus 4x minus 12. This entire differentiation. Now let us come for here. X cube derivation is 3x square. X square derivation is 2x. 2x into 3, 6x. X derivation is 1. 1 4s are 4. Minus 12. 12 is constant. Derivative of a constant is 0. Now what we have? 3x square minus 6x plus 4 minus 1 by 3x square plus 4x plus 5. 3x square. X square derivation is what? 2x. 2x into 3, 6x plus x derivative is what? 1. 1 4s are 4. 5 is a constant. Derivative of a constant is what? 0. Derivative of a constant is what? 0. Hope you understood the procedure. A little bit lengthy problem, and you have to be very careful because it is a big problem. Every step is very careful. You have to do it. Now let us continue that. That implies 1 by y dy by dx is equal to half into 3x square minus 6x plus 4 by x cube minus 3x square plus 4x minus 1 minus 6x plus 4 by 3x square plus 4x plus 5, because these two can multiply, these two can multiply. Now here 1 by y here is divided, comes this side, multiply. That implies dy by dx is equal to y by 2 into 3x square minus 6x plus 4 by x cube minus 3x square plus 4x minus 1 minus 6x plus 4 by 3x square plus 4x plus 5. Now what is the meaning of y? What is the meaning of y? This entire problem we have considered as what? Y. So that implies dy by dx is equal to 1 by 2 into square root of x minus 3 into x square plus 4 by 3x square plus 4x plus 5 into, here the fraction, 3x square minus 6x plus 4 by x cube minus 3x square plus 4x minus 1 minus 6x plus 4 by 3x square plus 4x plus 5. This is about our final answer. So finally the derivative of the function is half into the value of y. What is the value of y? Square root of x minus 3 into x square plus 4 by 3x square plus 4x plus 5 into 3x square minus 6x plus 4 by x cube minus 3x square plus 4x minus 1 minus 6x plus 4 by 3x square plus 4x plus 5. This is the derivative of the given function. So whenever we have this kind of problem, which method we are following? We are following the method of logarithmic differentiation. Logarithmic differentiation. So you may have a little bit confusion in this problem. By solving another 2-3 problems, definitely you can have more clarity about this method. Now let me explain example number 31. Let us come for example number 31. What is given? Differentiate a power x. Differentiate a power x. It is not exponential function. It is not in the form of e power x. Which is an exponential form, but not exponential function, which is in the form of exponential form. So differentiate a power x with respect to x, where a is a positive integer or positive constant. They have given that positive constant. Constant means it may be a real number. Now let us see how to differentiate. It is also, we are going with the method of logarithmic differentiation. Given y is equal to a power x, apply log on both sides. Logarithm we always write shortcut log. That is log y is equal to log a power x. That implies log y is equal to x into log a. Since we have a formula of the log a power m to the base b is equal to m into log a to the base b. Whenever we have an exponent, that exponent comes as a coefficient. Here also x is nothing but what? Exponent. It comes as a coefficient. Differentiate on both sides. Differentiate on both sides with respect to x. Differentiate on both sides with respect to x. That is d by dx of log y is equal to d by dx of x into log a. D by dx of x into log a. That is log x. Log x differentiation is not 1 by x. But in place of x, what we have? Y. So again we need to differentiate y, so that we have dy by dx. dy by dx. Now log a is nothing but what? Constant. Log a is nothing but what? Constant. So you have log a. So what we have? Log a. And x. What we have? X is nothing but a variable. X is nothing but what? A variable. Otherwise, we can go for UV method. You can go for what? UV method. Means even when we apply UV method also, because x is a function, log a is also a function. It is in the form of u and it is in the form of v. It is in the form of u, it is in the form of v. So when we go for differentiation of these, we have x into d by dx of log a, d by dx of log a, plus log a into dx by dx. In this case, d by dx of log a is nothing but what? Constant. Constant derivative is nothing but what? 0. 0 into x is nothing but 0. So what we have here? 1 by y into dy by dx is equal to 0 plus log a. dx by x is nothing but 1. So we have 1 by y into dy by dx is equal to log a. dy by dx is equal to log a. Now, here y is divided, comes this side, multiply. dy by dx is equal to y into log a. That implies dy by dx is equal to y. What is the meaning of y? A power x. So a power x into log a. So the derivation of a power x is nothing but what? A power x into log a. Here instead of applying the UV method, directly also you can apply. What is the direct method? So directly you can consider log a. Directly you can consider log a is constant. So we can write log a outside. Then we go for differentiation of only x. Then we go for derivative of only x. So that we have log a. d by dx of x. The derivative of x is nothing but what? 1. So log a into 1 is log a. Y is here divided. Comes this side multiplied. Y into log a. Y is nothing but a power x. So derivative of a power x is nothing but a power x into log a. Earlier we had an exponential function. d by dx of e power x is nothing but what? E power x. Now we have learned another concept. d by dx of a power x. What is the derivative of a power x? A power x into log a. These are the another concept of logarithmic differentiation. So example number 31. Differentiate a power x. Now this problem means this we are going to use as a formula in our further concepts. Wherever we have exponential function, d by dx of e power x is nothing but e power x. Wherever we have d by dx of a power x, means we are going to use the formula a power x into log a. This is about example number 31. Now we have the another example number 33. Find dy by dx. Find dy by dx if y power x plus x power y plus x power x is equal to a power b. It is a lengthy problem. We have to do very carefully. Means here x and y are the variables. A and B are nothing but constants. At a time we can't solve this problem, we have to go for part-wise. Means we should consider this is one function like u, this we have to consider like v, this we have to consider like w. So we have to go for differentiation of u function, differentiation of v function, differentiation of w function, then finally we should add it. Finally we should add it. So let us see the problem how to solve. Given that, what is given for us? Y power x plus x power y plus x power x is equal to a power b. Let u is equal to y power x, v is equal to x power y, w is equal to x power x. That is, I have u plus v plus w is equal to a power b. Differentiate on both sides with respect to x. That is, we have du by dx plus dv by dx plus dw by dx is equal to d by dx of a power b. That implies du by dx plus dv by dx plus dw by dx is equal to 0. Now this is equation number 1. Why here we have 0? Because here and here both are constant. So derivative of a constant is nothing but 0. Now what I require? I require derivative of u function, derivative of v function, derivative of w function. Now for finding derivative of u function, finding derivative of v function, finding derivative of w function, then by adding all these, definitely we have our answer dy by dx. Now we have three parts. First part is finding differentiation of u, finding differentiation of v, finding differentiation of w, and finally adding all those three. Now let us see here. Part 1. Now u is equal to, what is u function we have taken? Y power x. What is the function we have taken? Y power x. It is in the form of exponential form. Whenever we have exponential form, which method we need to apply? Logarithmic differentiation. We need to apply the method of logarithmic differentiation. Apply log on both sides. That is, log u is equal to log y power x. That implies log u is equal to x into log y. As we know that the exponent comes as a coefficient. Now we go for differentiate. Differentiate on both sides. Differentiate on both sides with respect to x. Differentiate on both sides with respect to x. When we differentiate on both sides, what we have? D by dx of log u is equal to d by dx of x into log y. That implies log u means 1 by u into du by dx. Here it is in the form of uv function. X is a function, log y is also a function. uv method, product rule. We have to apply which rule? Product rule means x into d by dx of log 1 plus log y into d by dx of x, log y into d by dx of x. That implies 1 by 2 into du by dx is equal to x into log by derivative is 1 by y into dy by dx plus x derivative is 1. 1 into log y is nothing but what? Log y. 1 into dy by dx is nothing but 1. 1 into log y is nothing but log y. That we continue here once again. What we have? Du by dx is equal to u into y by x into dy by dx plus log y. That implies du by dx u. What is u? We have considered y power x. So y power x into y by x into dy by dx plus log y. That implies du by dx. Let us multiply y power x inside. So we have y power x into y by x into dy by dx plus y power x into log y. That implies du by dx y power x into 1 y power x plus 1 by x into dy by dx plus y power x into log y. This is about part 1. This we need to remember. So just we got only du by dx. In the same way, we are going to find dv by dx. In the same way, we are going to have dw by dx. This is about part 1. This is about part 1. Now we go for part 2. Now let us come for part 2. What is part 2? Now v is equal to x power y. Apply log on. Apply log on both sides. When we apply log on both sides, what we have? That is log v is equal to log x power y. That implies log v is equal to y into log x. Differentiate on both sides. Differentiate on both sides with respect to x. That is d by dx of log v is equal to d by dx of y into log x. Means d by dx of log v derivative is 1 by v into dv by dx, which is in the form of uv, product rule. So y into d by dx of log x plus log x into dy by dx. That implies what we have? 1 by v into dv by dx is equal to y into log x derivation is nothing but 1 by x plus log x into dy by dx. Here v is divided, comes this side, multiply. That implies dv by dx is equal to v into y by x plus log x into dy by dx. So dv by dx is equal to v. What is the meaning of v? X power y into y power x plus log x into dy by dx. Let us multiply inside. dy by dx is equal to x power y into y by x plus x power y into log x into dy by dx. That implies dy by dx is equal to, here x power y, here x. So we have x power y minus 1 into y plus x power y into log x into dy by dx. This is about part 2. This is about what? Part 2. Previously we had part 1, which is du by dx. Now what we have? dv by dx. Next, what is required? dw by dx. Now we need to find part 3, that is derivative of the function w. Now w is equal to x power x. Apply log on both sides. Apply log on both sides. When we apply log on both sides, what we have? That is log w is equal to log x power x. That implies log w is equal to x into log x. Differentiate on same procedure, nothing is different. Differentiate on both sides with respect to x. That is dy by dx of log w is equal to dy by dx of x into log x. So derivative of log is nothing but 1 by w into dw by dx. Here we are going for uv rule. So x into d by dx of log x plus log x into d by dx of x. Then what we have? 1 by w into dw by dx is equal to x into derivative of log x is nothing but 1 by x plus log x into derivative of x is nothing but 1. That implies 1 by w into dw by dx is equal to x can get cancelled. We have 1. Log x into 1 is nothing but log x. Here w is divided, comes this side, multiply. dw by dx is equal to w into 1 plus log x. dw by dx, w is nothing but what? X power x. So x power x into 1 plus log x. This is about part 3. So now what we have done? We derived function u, function v and function w. Now I have du by dx, dv by dx, dw by dx. All the 3 derivatives I know. Now all these 3 derivatives, let us substitute in equation number 1. Now equation 1. What is equation 1? du by dx plus dv by dx plus dw by dx is equal to 0. Now, this is the du by dx derivative. We have done part 1. Y power x minus 1 into x into dy by dx plus y power x into log y dv by dx x power y minus 1 into y plus x power y into log x into dy by dx dw by dx part 3 x power x into 1 plus log x is equal to 0. What is required for us? They ask you to find dy by dx. Where we have dy by dx? Here I have dy by dx and here I have dy by dx. So those two terms we can keep on LHS side, remaining all terms we can send to RHS side. That is, here I have y power x minus 1 into x, there I have x power y into log x into dy by dx is equal to, what I have done? Here I have taken dy by dx and there I have taken dy by dx is common, so that y power x minus 1 into x plus x power y into log x I have. Remaining all terms we can send to the RHS. Now this is plus term, goes that side, minus term means minus y power x into log y, and this is the term goes that side, minus x power minus 1 into y, and this is the plus term goes that side, minus x power x into 1 plus log x. Now, from all these terms, I can take minus common, and this is the multiplication, goes that side, division. So, finally what I have, dy by dx is equal to minus of y power x into log y plus x power y minus 1 into y plus x power x into 1 plus log x by, and this term comes here denominator, y power x minus 1 into x plus x power y into log x. This is the derivative of the dy by dx. A lengthy problem, we have to do very carefully. First we go for derivative of u, derivative of v, derivative of w, and finally adding, and we require dy by dx, so that identifying the dy by dx terms, taking on LHS side, remaining all terms sending to RHS side, then simplifying. This is the final derivation of dy by dx. This is about example number 33. Still we have many problems by applying the method of logarithmic differentiation that we continue in our next class. Thank you.